Hello students, welcome back to the tetrahedron chemistry classes. I am going to start a series on the reaction mechanism which will be very helpful for you to develop the skills by which you can solve the organic reaction mechanisms. We will do the numbers of the problems in this particular series, and different kinds of the examples I will take in this series, so that you may have not you may have, you will definitely have a better idea about the organic reactions and their mechanisms. So in this series, the very first reaction which I am going to discuss is, you can see here, uh, lactone synthesis, how we can synthesize the lactones, right? So if you don't know what are the lactones, so lactones are the cyclic esters, right? So how we can synthesize these cyclic esters? There are various methods, but a very common method, and such type of reactions are very important for the JEE mains as well as for the JEE advanced, and sometimes in the 2 marker questions you may have such type of the questions in the CSIR net as well, right? So you have seen this starting material, you can see here this starting material is given here, and this starting material actually in the step 1 reacting with the Grignard reagent, and for your information, only 1 mole of this Grignard reagent is given in the question. So I am writing 1 mole here, only 1 mole is there, okay, because we need to control the reaction, right? And after that reaction with the Grignard reagent, second step will be the uh, you see the reaction of the product with the water, or you can say the dilute acid you will use in this particular reaction. So what is this compound actually? So first of all, you should know this thing. Say this is your functional group, right? This is your functional group ester, and this keto is your now prefix. It will treat it as a prefix, right? Second functional group it is there. So if you see here, so this carbon is the alpha, this carbon is the beta, and this carbon is the gamma, right? So at gamma position you are having the ketonic group, so you may call this compound as the gamma keto ester, right? And these are the very important starting material in the synthesis of the lactones, cyclic esters. So how the reaction goes actually? See, if you recall your basic organic reaction mechanism of your class 12, then you know this Grignard reagent, which is a very famous reagent after the name of the Victor Grignard, can easily react with this carbonyl carbon, right? Actually the nucleophilic addition will occur here, and how the reaction goes, it is something very important to note that. So what is important thing in that case? So for the beginners actually this is something very important, right? See, this is CH3, this is Mg, and this is Br, right? This is given here. You know, in short, your bromine is 2 positive, right? And your Br is 1 negative. So when 2 positive and 1 negative is there, so overall this species is actually positively charged, right? So this is the, just for the sake of the understanding, right, how we can understand the positive and the negative part in the Grignard reagent, right? Because magnesium is 2 positive, Br is 1 negative, generally you all know. So 2 positive, 1 negative will actually overall give you the 1 positive. That means this methyl part is the negative part. You should know this thing, right? Now you can go for the reaction and see. However, you can see here this ester part is there, and this gamma position where keto is also there. So you see in the beginning, if you are a very beginner in the organic chemistry, then you may think that this Grignard reagent can react with this ester carbonyl group. See, there are two things. First of all, I have given only 1 mole, and whenever you have the choice between this, then this ester and the keto. So ketones are actually more reactive towards this Grignard reagent rather than this one. So please remember, whenever you have been given such type of the condition, then always you will react this Grignard reagent to the carbonyl carbon. So how the reaction goes? So now you know. See, when this Grignard reagent approaches to this one, say I am writing in that manner, my CH3, Mg and Br, okay. and I already told you this part is positive and that part is negative, right? So where under the influence of the Grignard reagent, when the reaction start in the solution, the electromagnetic effect will take place and the electron pair will shifted onto the oxygen atom, and this oxygen will become negatively charged, right? And that negatively charged oxygen will grab that part, okay, and this negatively charged CH3 group will join to this carbonyl carbon. So what you will have in that case? Then you will have, say, CH3 is here and this is carbon single bond oxygen, and this will have the MgBr. Why MgBr? Because this this oxygen, actually the electron pair present on this oxygen is taking up this MgBr part. So it is OMgBr. This is the very basic reaction, okay. And then the CH3 part will go to this carbonyl carbon. Rest thing is quite same, CH2, CH2, okay. This is C double bond O, this is O, CH2, CH3, right. So this is very basic reaction which you have studied in your class 12. And see, you have taken what? You have taken your acid, right. So water will always be there, HOH, H positive and OH negative. So what would be the side product? You know, magnesium is there, one Br is there, okay, and one OH would be there, so that your magnesium would be 2 positive, okay. What you left with what you left with is H positive. This OH negative actually has gone to this MgBr and you have this byproduct, okay. So I am writing minus this one, and this H positive will go to the H and you will produce an alcohol from here. You will get the alcohol here, right. So your product would be not product exactly, your next compound, say C, CH3, okay, and then OH is there, and then you are having the CH2, and then another CH2 you are having, and then your C double bond O, O, CH2, CH3. This part is here, okay. So up to this stage there is no problem. You have simply converted this carbonyl compound, that is ketone, to the alcohol. Because I need some more space, so I am drawing this structure in the next page, right. I have drawn that structure here actually, right. This is exactly the replica of your earlier structure, right. The only mode of writing of structure is different in my this current form. So two of the methyl group and this OH. Now the very important thing you should know, this is the methylene group, this is another methylene group, and this ester is the electronegative moiety. Earlier your ketone was already your ketone electron withdrawing moiety. So these methylene groups which are present in between the two electron withdrawing groups, their hydrogens are acidic in nature. So what can happen? One of these hydrogens we can liberate as actually your from this methylene group. So beta elimination will occur in that case. If you consider this OH as now just a new labeling of the carbon, if this is alpha, then this would be your beta. At beta position you will remove the hydrogen, that means beta elimination. You can call this reaction as beta elimination, sort of beta elimination, not exactly. So how I can write? So I am deleting this 2 from here, okay, and writing this H here. So what can happen in the next step? It's very important, okay. Say this OH negative and this H positive, they will combine and the water molecule will eliminate from here, and this electron pair will be dropped onto this position and you will get an alkene. So how you will get the alkene? This is your CH3, no problem. This is your another CH3 and this was your carbon. Now this is a double bond carbon, this is H, this is CH2, and then your ester moiety C double bond O, O, CH2, CH3. So you have converted your ketone into the alkene with the help of the very basic reactions which you have studied in your class 12th, 11th and 12th, right? So now the important thing is that what we can do, we can number the carbon in order to form the lactones, and here I am going to form the gamma lactone. So first of all, you should know we may have the beta lactone, gamma lactone, right, delta lactone. See, if you have the four membered lactone, four membered cyclic ester, four member cyclic esters, right? So they are known as the beta lactones. Okay, if you have five membered cyclic esters, then they are gamma lactones. If you have six membered cyclic esters, then they would be your delta lactones, right? So here what I am doing the numbering, how I can do the numbering in that case. Okay, so this is something very important. Say this is 1, this is 2, this is 3, this is 4 and this is 5. Okay, so this numbering has nothing to do with the IUPAC numbering. This is just the numbering, random numbering. You can start from the either end. You can start with this oxygen as well, right? It will not make any difference. So in short, I am having the 5 atoms in that case, and among these 5 atoms, one is the oxygen, rest are the carbons. Okay, now the next very important thing is that very important step, which is known as the cyclization. Okay, so how the cyclization will go in that case? This is something very important for you. Okay, say this electron pair, two electron pairs are there on this oxygen, right? See, I hope you are aware about the fact that oxygen always carries the two lone pairs on it, right? And it's all entire family. Halogens carries 3 lone pairs, nitrogen carries 1 lone pair, etc, etc. Okay, so it is very important in the reaction mechanism that you should always show the presence of the lone pairs, negative charges, right? So what can happen? This electron pair can attack onto this carbon and this electron pair will shift here. So when this happens actually, so this carbon number 1 and this oxygen number 5 will make a connection and they will form a bond, and it will convert it into the 5 membered ring 1, 2, 3, 4, 5, in which there is a connection between the carbon and the oxygen. So first what you can do here, you simply draw your 5 membered ring. Okay, and you do the random numbering 1, 2, 3, 4, 5. This is the random numbering. Now you can see here at carbon number 1 carries what? 2 of the methyl groups. So what you can do? You can straightforward put 2 of the methyl groups over there. Okay, and your number 5 actually is the oxygen. So you straightforward convert this 5 as oxygen. Okay, there is no problem in that. And your number 4 is your carbonyl group. That means this should be a carbonyl group. So convert this into the carbonyl group by putting double bond oxygen. Okay, when you do this, then you will find carbon number 2 will carry the negative charge due to the shifting of this electron pair onto this carbon. Carbon number 2 will carry the negative charge. So straightforward you put the negative charge here. Okay, so you have formed this particular compound. Finally, what will happen? You have taken acid here. Okay, so this will grab this and you will have your product, and that product would be your 5 membered cyclic ester with 2 substitution of the methyl. This is actually your gamma lactone. Okay, so if you do the practice like that only, then you will have the benefits in solving the questions of reaction mechanisms, organic reaction mechanism. So this is my first problem which I have explained in this section, is your organic reaction mechanism. I hope you understood the things, and if you go in that manner, see, it is my suggestion to you, not only depend on the lectures of the others, you try to find your sample problems from the various magazines or your organic chemistry books, anywhere you can find, right? Wherever you find, you can find those problems and try to solve by your own, right? and once you will have such kind of the confidence in solving the problem, then it will be very very helpful for you. So I hope you understood the things, right? If you like the lecture, please give one like to this lecture, and don't forget to subscribe the tetrahedron chemistry classes, and do share with your friends as well. Okay, so that's it for today. Thank you very much.